Hi, everybody. Today is Wednesday, January 31st. So today you have your homework one due, right? So it's about session 7.1 and 7.
Professor, it said it was due February 1st. Today's the 31st.
It says February 1st? Maybe I clicked the wrong button.
Because I looked at it yesterday.
Oh, let me see. Isn't it January 1st?
I think it's different on ours because when you
It
pulled it up
is.
initially, like when you were showing us, it says the 31st on there on our view system. Yeah, and it says February 1st at like 1:59 a.m.
Ah. Eh?
Yeah.
And you're, eh? Why? Am I in a different time zone?
I know,
Might be.
if you look at student view, I think it shows it at February 1st.
Yeah.
Oh, so your due date is different than my due date.
Oh.
Still,
Am I in a different time zone?
it might be.
But anyway, I don't know what's wrong with campus. Well, I want you to see you're working on your homework. So your first attempt is by midnight, and then after that you can continue to work on your homework until you get perfect scores. So the due date, the setup in Canvas, not really matter because you can still working on your homework. But I just want to see something in your homework scores so I know you're working on your homework. Okay? Yeah. But thank you for telling me. Now I'm worried about the quiz. So, do you see anything in the quiz? So, do you see any quiz here?
Yeah, due February 6th.
Oh my goodness! That's so weird. What should I do? Like, how many times? How many hours? Yeah.
Uh,
2 hours difference. Okay.
it's always days actually. Yeah, so it's pretty close.
Yeah.
Like you'll still have to do it at night.
Okay.
Or by the
Exactly. It doesn't even matter.
Interesting. So maybe my canvas think I'm in the Eastern time zone.
It might.
Are you in the middle?
Yeah, we're like, yeah.
Okay. I have no clue. Interesting. Okay. Yeah, something wrong with the quiz and you like the midnight you cannot submit, you can feel free to email me. Okay. And remember you can open a second attempt right away to do the quiz. Yeah. Alright. So hopefully it won't be a problem. If you need more time, just open a second attempt right away and continue to work on it. But if you use more than one attempt, just kind of email me and tell me. I just want to know what is going on. Yeah. Okay. Interesting. Thank you for letting me know. Okay, so let's continue. So last time we were talking about session 7.4, fundamental theorem of calculus. It kind of say that we find the antiderivative and then we plug in the upper limit of integration, subtract, we plug in the lower limit of integration. Yes, everybody? So like this problem, no product rule or quotient rule. So we want to simplify or use substitution. But in this case, because this is not a composite function, we cannot use substitution, right? If you have like the square root is from here to here, like square root of t minus 1, then you probably have a composite function. You let u be the inner function, u minus 1. But this square root is just of the t, then we don't need the u substitution. So we simplify it until we get here. Then we can find the antiderivative. So 3 types of antiderivative. The power rule, integral x to the n is x to the n plus 1 over n plus 1. The second one is exponential function. What's integral e to the ax?
So 1 over a e-ax.
Yeah, 1 over a e to the ax. The third one, 1 over x, ln absolute value of x. There's just 3 type of functions. Okay, yeah. So, and then last time we were working on part B. We figured out this is a product, but we don't have product rule, so we distribute. And this is 4 times cube root of x. So x to the 1/3. And then we multiply them, and we simplify. And thank you. See, the x cancel. We're now able to integrate. With can you just integrate this thing? No, we never learned how to do this one. So thank you that when we distribute the x cancel, now we're able to integrate this exponential function. And also this one, we have x over x squared is 1 over x. So we're ready to integrate. Okay, so that equals, we integrate them. So, or do you want to copy one more time? Yeah, we can copy one more time. So that's the integral 8x to the 4/3 plus 2 e to the 5x minus 14 times 1 over x dx. So we integrate 8 constant multiple, same here. And then x power, what do? What do you do? Add 1? What do you get if you add 1? Yeah, 7 over 3 over 7 over 3. But it's the same as you multiply by the reciprocal, right? So you kind of put the 3 up there. So it becomes 3 over 7. Yes. That is the first term. The second term, constant multiple, the 2 stay here. How about e to the 5x? 1/5 e to the 5x. Good. Minus 14, constant multiple stay here. What's integral of 1 over x? ln. Yeah, absolute value of x. Now we evaluate from 1 to 2. Okay, so we find the antiderivative. Do we need to do plus c? Plus c? No, for definite integral. Because if you do plus c, remember you plug in 2, you have plus c, and minus, you plug in 1, you have plus c. But c minus c cancel anyway. So then we don't need to do the plus c because they cancel anyway. All right, so that equals 3 times 8 is 24 over 7. And that's 2 to the 7/3 plus 2 over 5 e to the, what is 5 times 2? 10 minus 14 ln absolute value of 2 is 2. So this is what we get after we plug in 2. And now we plug in 1. Make sure you put the parentheses. So we plug in 1. What do we get? 1 to the whatever power is 1 to the 7/3 is 1 to the any power is 1. Right? Okay, attendance. Okay. So we got 24 over 7. And then plus 2/5 e to the 5 times 1 is 5 minus 14 ln 1. By the way, what is ln 1? Yeah, 0. Yes. So we have something like this. Okay. So now you can put this in your calculator and get, let's see, give me 4 decimal places. What do you get? 24 over 7 times 2 to the 7 third plus 2 over 5 e to the 10 minus 14 ln 2 minus parentheses. This term 24 over 7 plus 2/5 e to the 5 parentheses. What do you get?
I got 62.734. Oh, wait, I'm sorry. 0.794.
0.794.
Yeah.
Ah, but e to the 10 should be so big.
Wait, e to the 10?
Mm-hmm.
Oh, you know what? I only did the ones in parentheses. That's why I don't get that.
Oh, okay. So how about the whole?
Why don't we separate so it's 8, 3x over 7, 7 to the third power? Why do we separate the 3 and the x?
The 3 and the x?
Yeah. Because if you go down to the next line, it's 24 over 7. And then we go
Oh,
over.
because there's no parentheses.
Okay.
It's integral x to the m equals x to the m plus 1 over m plus 1.
Mhm.
So this number is not inside. So it's not like x over m plus 1 to the m plus 1. So this number does not have the exponent.
Okay.
Yeah. So that's why it's over 7 over 3, but you kind of put the 3 upstairs. But the 3 does not have the power center.
Okay. So we can separate the 3 and the x.
Yeah,
Because they're
yes.
multiplicative. Okay.
Yeah, we don't have a parenthesis.
Okay.
So
Yeah.
separate it.
Okay.
So then we can multiply the 8 and the 3.
Okay.
Yeah, yes. Good. Okay. So do you get a number? It's so big?
Yeah, big.
So yeah, what is that?
I got 8,884.374.
Like that?
Yeah.
But e to the 10 is so big, right?
Yeah.
Is it bigger than that? What do you get? Mine, I got 8,755. 8,000 what? 8,755. Oh, 8,755. Point. Oh, 367. 367. Okay. Yeah, actually, in the exam, if you get this, I will give you all the points. yeah. Okay, because our goal is to find the antiderivatives. Yeah. Okay, and then yeah, you get those exact number. Yeah, that's fine. Okay. Continue. Robot has been programmed so when it starts to move, its velocity after t seconds will be 3t squared feet per second. How far will the robot travel during the first 4 seconds of the movement? And part B, how far will the robot travel? Thank you. During its next 4 seconds of the movement. So this is the velocity. We know velocity is the integral of acceleration, and the displacement is the integral of the velocity. Right, everybody? So to find the displacement, okay, we have part A. How far it travels during the first 4 seconds. So 0 to 4, and then the velocity dt. Right? That is the displacement integral of the velocity in the first 4 seconds. So 0 to 4. So 0 to 4, v is 3t squared dt. Okay. So what is the integral of 3t squared? T cubed. Yes, it's 3 times t cubed over 3. 3 cancel. We get t cubed from 0 to 4. Bless you. And so we plug in 4 first. So 4 cubed minus, we plug in 0. 0 cubed. Oh, what is 4 cubed? Yes, 64. Very good. Oh, so we travel 64. What's the unit? If the velocity is feet per second, then the displacement is feet. Yes. Okay. That's part A. Part B. Oh, by the way, from the picture, part A represents the area under the curve from 0 to 4. Okay, everybody? That's part A, the displacement. Part B. Next 4 seconds. That means our bounds are from where to where? Next 4 seconds. So 4 to 8. Yes. We have t dt. So 4 to 8. 3t squared dt. Again, what is the integral of 3t squared? T cube, right? From 4 to 8. So we're using 8 cube minus 4 cube. What is 8 cube? You can use your calculator. 512 minus 4 cube is 64. What is 512 minus 64? Thank you, 448. What's the unit? Feet. Yes. Okay. So that is example 2. In terms of the picture, what are you going to do? You're going to, woo! And 4 to 8 right here. So it represents that area. Yes. So that is the displacement. And remember, displacement, it could be positive, it could be negative. It depends on the direction, right? But distance is always greater equal to 0. Remember, displacement is like the next area, and then distance is the total area. Okay. Let's continue. Example 3. A company determines its marginal cost for production in dollars per item. So we have the marginal cost 4 over square root of x plus 2 when producing x thousands items. Find the cost of increasing production from 4,000 items to 5,000 items. Okay, so we are given marginal cost. To find the cost is the integral of marginal cost. Right, everybody? If you're given rate of change, then the integral of the rate of change of the cost is And we're looking for the cost from 4 to 5. And then you integrate the marginal cost, the x side. So this is the cost from 4 to 5,000 items. Integrate the marginal cost. So similarly happens to if you're given marginal revenue. How do you find revenue? The integrate the marginal value, right? Or they give you marginal profits. You integrate the marginal profits to get the profits. So we integrate that. But it's not in the standard form. So let's rewrite it. So 4 times x to the 1 power. Negative 1/2. Good. Plus 2 dx. How do you integrate? The 4 stays here. What is the integral of x to the minus 1/2? At 1, then it becomes x to the 1/2. You divided by 1/2 is the same as? Yeah, bring the 2 up, multiply by 2. Is that okay, everybody? How about integral of 2? 2x. Yes, that's 2x. So this is the antiderivative. So we evaluate from 4 to 5. Okay. What is 4 times 2? 8. Yes.
Right.
8. And by the way, this is 4 times 2. This is not 4.2. You gotta be careful. Right? Not 4.2. Okay. 8. We plug in 5 to this. This is like square root of 5. Okay? So square root of 5 plus 2 times 5 minus parentheses. So make sure when you evaluate the lower limit, if you have more than 1 term, please put a parentheses. Because I'm so afraid that if you forget the parentheses, then the next term, the sign will be wrong. Okay, we plug in 4. So 8 times, what is square root of 4? Square root of 4 is 2. Plus 2 times 4. Okay, so 8 square root of 5. 2 times 5 is 10, right? And this is 16 plus 8, which is 24. Oh, we get 5 square root of 5. 10 minus 24 is negative 14. Yes. So this is the exact number. Let's put this in a calculator and give me 4 decimal places. What do you get? What do you get? Give me 4 decimal places. Huh? I make a mistake?
8 times the square root of 5 minus 14,
Yes.
which would be 8.67, or sorry, 6274.
6274. Thank you. You have the same answer? No?
No, we lost.
Yes.
So when we plugged it in, so we got to a 4.
Oh, it's 4 times 2 is 8.
Oh, never
And
mind.
then square root of 4 is 2. Yeah.
Thank you.
You're welcome. Do you have the same answer? No, not the same answer? Not the same? Oh, okay. So what do you get? 3.885. Like that? So, okay. So 3.8885 is our answer. Okay. Maybe the Did you use the phone or calculator?
No, I use a calculator.
No. Did you type the whole thing in one line?
Oh no, I made a mistake. I see right.
Oh, you. Oh, okay.
Yeah, I got 3.88.
Yeah.
Okay. Okay. Yeah. All right. So that is example 3. Okay. Example 4. So if we have something like this, what do we do? This is a product. Do we have product group? No product group. So, we should use substitution. And do you see a composite function, the square root of some things inside the square root? Yeah, so this is a composite function. We let the things inside the square root to be u. So this is a u, using u sub. Okay, and this is that for the integral, using u substitution. There are 2 ways you can compute. So either the first way is you want to change the x values. So these, the 0 to 5, they are x values. So you want to change the x values to u values. And then after you integrate, you plug in the u. That's the first way. The second way is you're going to keep the x value, but after you integrate, you need to get the x back. Then you plug in the x. So 2 ways. Either change the x value to u values, then plug in the u. Or you get the x back and then plug in the x. So never plug in the x values into u and don't plug in the u values to x. Yeah. Okay, let's do both. And then you tell me which way you like better. Okay, the first way, change the x values to u. Okay, so we know u is the inner function, 25 minus x squared. Remember step 1, figure out the u. Step 2, find the du. What is the du? X negative 2x dx. Yeah, so negative 2x dx. And in our integral, we have x dx. So we want to solve for x dx. So x dx is how many du? Yeah, negative 1 over 2 du. Yes, everybody? Okay, now step 3. You want to get a u integral. Now, 0 and 5, they are x values. So if you want to get the u integral, you put u of 0 plus u of 5. And then the x values, now I want to get a u integral, so it should be u of 0 and u of 5. And then x dx is negative 1/2 du. Where do you put the negative 1/2? In the front. Where do you put the du? At the end. Right, everybody? So minus 1/2, put it in front. And then the du, put it at the end. What's that? What's this? U. And it's a square root of u. Right? So we change to u integral. So make sure you change the x values to u values. So we get minus 1/2. So yeah, first way, we want to actually compute what is the u values. So u of 0. Look at this. This is a u. If you plug in x as 0, what do you get? When you plug in x is 0, u is 25, right? So u is 25. How about when x is 5? If you plug in x is 5, what do you get? 0. We plug in the u of 0. If you plug in x is 0. So we plug in x is 0. 25 minus 0 is 25. U of 5. We plug in x is 5. So 25 minus 5 squared is 0. So they are u values. And square root of u is u to the what power? 1/2. Yes. Okay, we get that. All right, let's integrate. What is the integral of u to the 1/2? Yes. U to the 3/2, and then you divide it by 3/2. But what do you do to the 2? Yeah, move it up. Aha. So now evaluate from 25 to 0. So far, so good. What can we cancel? The 2. Yes, we can cancel the 2. And now we plug in the u values. You see, these, the 0 and 25, they are u values. So we plug in 0 first. Oh, do you see if we plug in 0? 0 to the whatever power is 0, right? Yeah, so we have minus 0. And then minus, do you see minus negative become positive? And then we plug in 25. So 25 to the 3/2 over 3. Yes, everybody? We plug in 0, minus, but because there's negative, minus negative becomes plus. We plug in 25. Okay, what's this? This is square root. What's square root of 25? 5. And this square root of 25 and then cube it. So what is 5 cubed? 125. So our answer is 125 over 3. Okay? So that's the first way. We change the x values to u values, and then we plug in the u. Do we need to get the x back? No. Okay? Just plug in the u values for u. Any questions about this way? The second way is similar, but you don't change to the u values. So what do I mean? Okay, the first step is to say you let u be 25 minus x squared. Second step is to say du is minus 2x dx, and then minus 1/2 du is x dx. I kind of just copy what we did, okay? But then the third step, when you plug in minus 1/2 u of 0, u of 5, u du. So don't evaluate the u value. Keep it as u of 0 and u of 5. So continue negative 1/2 integral u of 0, u of 5, u to the 1/2 du. And then when you integrate, okay, let me wait a little bit and see what everybody copy up to that step. The idea is you don't want to evaluate the actual use. You just keep the x values there, and at the end, you put the x back, and then you get what you have. So far, so good, everybody? So we integrate. We get Oops, sorry. Okay, so we got u to the 3 over 2 over 3 times 2. Now evaluate from 0 to 5. Then the 2 cancel. So you want to get the x back. What is u? Yeah, 25 minus x squared to the 3/2 over 3. Now, after we get the x back, we can put 0 to 5. Because they are x values. 0 to 5, they're x values. And here, u of 0, u of 5, they are u values. So now we can plug in the 5 first. By the way, can I cancel this 2 and this 2? No. Because it's parentheses. This 3/2 is the whole thing. Yep, also 25. Oh, by the way, can I distribute? Can I put 25 to the 3/2 minus x
No.
cubed? No, yeah. For subtraction, we cannot distribute the power.
Can you square root it and then cube it?
Yes. Yeah, it's the same thing. Square root and then cube it. Yeah. So we plug in 5 first. So when we plug in 5, do you see we get minus 25 minus 5 squared to the 3/2 over 3? And then minus negative become plus. We plug in x is 0. Do you see 25 minus 5 squared is 0? Yeah? 25 minus 5 squared is 0. And then the second term is 25. Square root of 25 is 5. And then 5 cubed is 125. So 125 over 3. You see, we have the same answer. So you either change the u values to u and plug in the u, or you keep the x values. Don't change to u, don't evaluate to u, and just at the end get x back and plug in the x. Which way do you prefer? Changing to the u values or keep the x? The second one? Mm-hmm. So in the homework solution, sometimes you may see I change the u values, sometimes you may see I keep the x. Okay, so you can do them both ways. Okay, just as you like. All right, so that is 7.4. Any questions about 7.4? All good? Okay, so let's see. 7.5 area. Do you have the 7.5 handout? Okay. So from now on, try to print out the worksheets for the entire week because sometimes we may finish in the middle, then we will start the new section. Okay, so I can print out for you. So 7.5. How many of you need 7.5? Raise your hand. 1, 2? Just 2? Okay. Let's see. 7.5. 3. Okay. 3. Oh. See. 3 copies and let's see. Do 3 copies and staple. Oops. Okay, great. Yeah. You know. So,
Thank you.
you're welcome. Alright. So area between curves. Okay. So we know definite integral their area under a curve. Well, if we have two curves, then imagine the idea is very similar. This is the region. We cut it into a lot of rectangles. Now for each rectangle, do you see the width is still dx? But the height is going to be f of the x, the upper function, minus g of x, the lower function. So therefore, we got the limits, n goes to infinity, n is the number of the rectangles we cut, right? And the sum area of each rectangle, we have the height, which is f of x minus g of x, times the width is dx. Okay? So therefore, the formula becomes integral from a to b, and then the upper function, f of x, minus the lower function, g of x, times dx. So that's the formula for the area between curves. Okay? Now let's do examples. The first example, find the area of the region bounded above by the x-axis, bounded below by y equals x cubed, and bounded on the side by x equals minus 1. Let's draw the picture. So we have the x-axis, the y-axis, and 0 is the origin. Let's review the parent functions. Line. Move your hands. Line. Like this, right? Yeah, everybody move your hands. Line. Like this. X squared. X squared. Like this. Yeah, move your hands. X squared. It's like I love you, the U, right? X cubed. X cubed. Yeah, like that. X cubed. Square roots. Square root. Like that, right? How about cube roots? Cube roots. Like this, right? Cube roots. Okay. Absolute value of x. V, absolute value of x. How about 1 over x reciprocal? Like this. Like this. Exponential function e to the x. So it like that. And it passed through the 0.01, right? And it has a horizontal asymptote. And L of x. Like this. Right? Like that. And how about the trig function? Sine or cosine? Yeah, the oscillating between 1 and minus 1. Sine start with 0. Yeah? And cosine start with 1. Yes. How about tangent? Like x cubed? Tangent x. Like x cubed, but a lot of copy of x cubed, right? Cotangent, like that, but a lot of copy of that. Okay, how about secant? You know, secant is 1 over cosine, so you kind of flip it up, down. Okay, and cosecant, 1 over sine, so it's also up, down. So it's a math exercise. You know, there are some T-shirts print those math moves. Let me show you. I want to get one. So math move T-shirts. Yeah. Let's see. This is the one of the ones.
Have one of your students promote them.
Oh yes. Which one? Move math dance. Oh, maybe it said math dance. Oh, okay, like that one. Let's see. I like this.
You get somebody in class to This is promoted.
Yeah.
So what if I wear this during the test?
Oh, interesting. Circle. Yes. And for this one, I'm not sure. Yeah, we get that. We get that. Okay. All right. Yeah, I get a little color. Okay, it's 15 plus. All right. Oh yes, we should get orange. Okay, good. And we should get orange, and then we get a class photo. And look at the background.
Okay, you know what I think we should do? We get one. You should have one shirt. Have somebody promote it first, like somebody from here. It's like a mascot photo.
Okay, let's get back. So we know x cubed is gonna be like that, right? So let's draw some points. Okay, we can plug in like 0 cube is 0. We know it passed through 0, and 1 cube is 1. So we know it passed through 1. And -1 cube is -1. So we know it passed through -1. And what's 2 cube? 8. So it's so big, right? Okay. Let's make it like that. Okay. So this is x cubed. Y equals x cubed. So, and then we are looking for the region bounded above by the x-axis. So this means x-axis is above that region and bounded below by y equals x cubed, which means this curve is below the region and bounded on the side by x equals -1. So this is the region. Okay, so bounded above by the x-axis. So x-axis is above the region and bounded below by this curve. So this curve is below it and bounded on the side by x equals -1. So this is the region. We want to compute the area. So area is integral x goes from where to where? Yes, -1 to 0. And then we use the upper function. What's the upper function? The x-axis, it corresponds to what? What's the x-axis? Y equals to 0. Yes. So the upper function, okay, is the x-axis. X-axis, y equals to 0. The horizontal line. You know horizontal line is y equals a number. A vertical line is x equals a number. Yeah. So that's the upper function. Minus the lower function. Who's the lower function? Y equals x cubed. Yes, everybody? Mm-hmm. How do you integrate x cubed? How do you integrate x cubed? Yeah, x to the 4 over 4. Yeah. Evaluate from -1 to 0. Right, everybody? Okay, what number do you want to plug in first? 0. Oh, do you see when we plug in 0, 0 to the 4 is 0? Yeah, we just get 0. And then minus negative become plus, right? You plug in -1. What's -1 to the 4? 1. Oh. So this area is 1 over 4. Okay? Yes. So let's stop here and continue next time. Okay. Have a nice day. And remember to turn in your homework.